Hello everyone and welcome to AWCI's Limit Your Liability Series, Part 3. Today's topic, Firestop Inspections Explain, what contractors and inspectors need to know. My name is Tawin, AWCI's Education Program Manager. So before we begin, a few reminders. Mics are muted, and should you have a question at any time during today's broadcast, please submit it using the question box in your GoToWebinar dashboard. At this time, I'd like to introduce our presenters, Brent Johnson and Don Pilz. Brent is a nationally recognized subject matter expert in passive fire protection with nearly 2 decades of experience. Since 2014, he has led FireWise consultants to support clients on some of the nation's most complex and high-value construction projects. Brent has trained thousands of inspectors across the U.S. in proper Firestop special inspection techniques, helping elevate inspection standard nationwide, and he remains an active contributor to leading industry organizations and technical committees. With him is Don Pilz. He is AWCI's Director of Technical Services. He brings more than 37 years of experience in the construction industry as a drywall, lather, building envelope consultant, and product development specialist. So welcome to Brent and Don.
All right, we'll jump right into this. So some of the key takeaways we're going to present to you today. We're going to go into UL 2079 and ASTM E119. We explain the differences. They are very similar, but there's a few key differences that we'll explain. We're going to go over what's in the code, and this is really critical when it comes to liability. We want to make sure you're not caught off guard. So we're going to go into the code and how it pertains to fire stopping. We'll identify some contractor pitfalls, we got some stories, some images of what to avoid and how to avoid them. We're going to identify product selection performance. A lot of different products out there. Some of them work for better in certain situations, so we'll go over some of those. The role of the Firestop inspector, Brent's going to cover that, as well as best practices and resources. Again, you'll have this presentation in a couple of days. It'll be uploaded to AWCI, so don't feel like you have to take pictures of the slides. You'll be able to get the whole thing. So how does third-party Firestop inspection affect your project? You might be thinking, I've never had to deal with one of these before, haven't dealt with them in the past. That doesn't mean you won't have it this year or next year, because code requirements are tightening across all jurisdictions. Where do you get it from? It's in the International Building Code that mandates a third-party Firestop inspections for certain buildings, and Brent will cover that later on also. Just look at it this way, inspections are a good thing. They're going to ensure life safety, but they could also introduce some contractor liability if it's not done right. It's going to be scrutinized now, so it's important to do it right. Failing to prepare can result in failed inspection, delays, and some legal exposure. So again, staying on that construction defects theme, picture this scenario. You're in the middle of a construction defects lawsuit. You're meeting with your attorney. Their first question is, do you have proof that you did everything correctly and per code? You're going to see that per code a lot in this, because it is, if you're not complying with the code, that's what's going to get you in trouble. Okay, it really boils down to the beginning of this is the importance of pre-con. Now, why is that? Is because fire stopping assemblies are complex. They're going to involve a lot of multiple trades, electricians, plumbers, HVAC, carpenters, and sequencing is really important. Sequencing will and can impact the schedule. If you don't have early coordination, you're almost guaranteed delays, missteps, and improper installation. That's what we're trying to avoid. So I put together this checklist for you. I'm not going to go over every single one, but I will touch on the big ones. First off, confirm your total dynamic movement for your head of wall joints. You might have a set of drawings that show a single head of wall detail, an arrow pointing to it, and it might just say fire rated sealant. That doesn't tell you anything. You need to confirm what type of movement is needed. So you might have to RFI, you might have to ask for what that movement is. If you're a seasoned professional, you know what kind of conditions you're going to run up to, what kind of assemblies that you're going to need. So you could start putting together your third-party listing list. And if you see that something might come up that you need an engineering judgment, start early on that. And also, we'll go over this a little bit later, make sure it complies with the International Firestop Council's guidelines for EJs. What a lot of people kind of skip over, may not know, is fire stopping does start with the framing. A really good fire and stop inspector will start at the framing when they're doing their inspections. In other words, your header track is listed in that third-party listing, whether it's a deep leg, slotted, or a T-shape, it's listed there. The stud size, the gauge, mainly the stud size and the layout will be listed as well. And also the Z-clips to make sure it's the proper thickness for your spray applied fireproofing. That's all going to be listed in that framing in your third party listing. Coordinate with other trades. Don't get buried. I mean, you got to keep something in mind. As a carpenter, the other trades do not understand your Firestop system. Unless you share with it, unless you coordinate with them, they're not going to understand. Product selection. Confirm that your Firestop material provides the same movement for your shaft walls as your standard walls. There's a lot less shaft wall third-party listings out there. So make sure that they comply, make sure you're getting the same kind of movement, make sure that aesthetic fill material is what the architect's looking for. A lot of good, you could sometimes do a mock-up so they could see what it looks like. And then finally confirm the performance warranty for whatever the project requirements are. Make sure that Firestop provides that type of warranty. Now getting more into the details, this is something that's important though. Confirm and document your storage temperature of your wet material fire stopping. Take pictures, have it dated, track all your purchases, make sure you're not using expired material. This is really important to be on record. And then finally with QA and QC, hold pre-construction meetings with all the trades. This will really help you not get buried. Review the sequencing and the responsibility. If it is a high-end job, a hospital or something, consider hiring a third-party Firestop consultant. They could really help you walk through all of this stuff and make sure you don't have delays. So that construction defects, this is coming out of California. So SB 800 is the California construction defects law. A couple things to point out. When it comes to fire stopping, they actually do have a 10-year statute of limitations on the fire stopping. What does that mean? Well, the builder's got to warrant the fire resistant assemblies, alarm sprinklers for up to 10 years. Got to make sure they meet code, they perform correctly. If not, homeowners can arise a claim out of SB 800. Now, what we're talking here is more residential towers. Yeah, that's what we're talking in here. So it is a contractor's responsibility to make sure that everything is installed, code compliant methods, and whatever material you're using, make sure it has a performance warranty that's going to get up to 10 years. Why is it so important with this dynamic movement that we're talking about? Well, taking a look at how these come together, this is just a quick little illustration. You've got your studs. You notice that 1-inch gap. We're showing a gap in between the stud and the track. We got our drywall, we got our fill material. And what it is, it's that downward and upward movement right there. That's what we're talking about. We want to make sure that whatever that fill material, whatever that material is, it doesn't split, it doesn't crack. Let's face it, a lot of projects are using slotted track. If that splits or cracks, you're going to have smoke, sound, fire could go right through those slots. So that's what we're trying to protect. Question for you here. Can a third-party inspector fail your inspection based on the location of your framing screws or the location of your drywall fasteners after you've already passed a previous inspection? Some projects going out that have 3 or 4 inspections on there, and you could pass the first 3 and fail the 4th. So yeah, the question is, yeah, third-party inspector can fail it even though somebody else already passed it. Now, when you're looking at your third-party listings, the type of track will be listed in there. Just because you might see a UL logo on a track doesn't mean it's for all systems. In that third-party listing, you will see what types of tracks are listed. You see deep leg, 2-piece slotted, T-shape here, it'll be listed. And before we go any further, let me back up and go over the similarities between UL 2079 and ASTM E119. Okay, so they're both have a standard time temperature curve. Okay, so it's going to result in an hourly rating this test, 1 hour, 2 hour, 3 hour, 4 hour. It's going to result in that. It is a pass fail criteria. You can't kind of pass these. You have to pass the entire test. You can't get flame through, the heat transfer can't get through. Both of these are recognized by the building code, so that's why you're probably familiar with them. You see them listed a lot. ASTM E119 is going to test the walls, the floors, and the ceilings, while UL 2079 is going to focus on the joints between those assemblies. UL 2079 may also be subject to a hose stream cycle test and optional air leak. So that's kind of the difference. Now we'll go into what's on UL 2079 listing. All right, so you notice sometimes you will have on one side of the report, this is usually on the top part of the report, it'll say UL 2079, And then on the right side, you might see ULC S115. That's for Canada. And I color coded these so you could see how they're similar, right? We got the hourly rating over here. We got the F rating over here. We got the nominal joint over here in inches. We've got the nominal joint over here in millimeters. Movement is basically the same on both. And then the L rating, air leakage, is basically the same on both, slightly different ratings. But sometimes they'll be listed both on that same report. So there's not typically one for Canada and one for UL. Typically, they'll both be listed on that same report, and you could use them in Canada and the US. Now, as you go down that report, you'll also notice that in section 3, some of these listings might have a table. Personally, I like the tables. They're really easy to read. You'll see in that section there in the joint system, you're going to see, and this is again paying attention to the details, you're going to see what the max separation is at the time of installation. Okay, and then you're going to see the type of movement. If it's got a table, it's pretty easy to see. So you'll have your product listed here, your nominal joint listed here, and then what is the compression and the extension. Okay, so they're really easy to read if they're like that. If not, sometimes they're a little bit tougher to read, but this is one way that they do it. Keep something else in mind. Again, I was just showing you 100%. Now we're going to show 25%. Typically, 25% is going to be a fill material like a sealant in there. And keep something in mind. You might see a system. It might show a 1-inch joint. Let's say you're looking at your project documents, your blueprints, and you'll see at the header wall page that it shows a 1-inch joint. And you might be thinking, okay, it shows a 1-inch joint. There's sealant in there. I've got to provide 1-inch movement. Just because it's a 1-inch joint with fire sealant does not mean it's getting 1-inch movement. In fact, if you got here, it's a 1-inch joint. If it gets 25% movement, that's a 1/4-inch compression, 1/4-inch extension, 1/2-inch total movement. Okay, so out of that 1-inch joint, you're getting only 1/2-inch movement. So that's something to keep in mind. Again, the opposite is true when you get into more movement capabilities, 100%. That same 1-inch joint can compress down to 0. It could extend another inch and you get a total of 2-inch movement. So it's really important to see what the movement capability is so you know what type of movement is. And when you're working with the architect, ask what the movement capability. The joint size does not necessarily depict what the movement is. Now, also, again, pay attention to the details. A good third-party inspector is going to look at this. Now, as you scroll down your UL, your third-party listing, you'll come to a section where it's going to say the framing members. Okay, and this is what it's going to list: minimum size 2.5. Okay, so that's the minimum size stud I could use is 2.5. That means 3 and 5, 4-inch, 6, 8-inch. That's all okay. It's just minimum 2.5. Max stud separation 24-inch. Okay, I could still do 16. I just can't go over 24 inches on center, so they'll look for that. Notice this next line. A lot of people miss this. The studs, what could it be cut to? Well, this says it could be cut 1/2 inch to 3/4 inch less than the top web of the track. So they're telling you how much you could cut it. That means an inspector could go in there with a tape measure and measure from the top of the track to the underside of the track. I'm sorry, top of the stud to the underside of the track. What is that space? They can measure that, and it's listed on these listings as well, the third-party listing. Now look at this next part. The steel studs nested into a non-slotted ceiling runner. What's that? It's a deep leg track. Or it says it could go into a slotted track. So both are listed. So you know right there you could use deep leg or slotted. Not all third-party listings are going to have a slotted track listed on there. Why is that? Slotted track's a little harder to pass. You got all those open slots. So not all UL listings will have a slotted track in there, so be aware of that. Now let's get down into the gypsum board. This is a tough one right here. It says a screw attaching the gypsum board to the studs coming down from the top of the wall have to be located 4 to 5 inches down from the deck. Earlier I was saying, can a third-party inspector fail your inspection on the 4th go-around? Yeah, and this is where it typically happens. Okay, so they will look at where this screw is located and make sure that that screw is in the right spot. Okay, here's a few key things for engineering judgments. This is a great guideline. Comes from the International Firestop Council. I'll touch on a few of them. There's a lot here, but I'll touch on the main ones. First off, make sure it's a qualified issuer. Make sure it's by the manufacturer, or Brent will go over this a little bit later, qualified testing laboratory. That's another way to get an engineering judgment. You could actually just go and test it. The issuer must have thorough knowledge. What's that mean? They shouldn't typically done by a salesman. It should be somebody with knowledge from that company. It needs to be based on previously tested listed assemblies, systems. So in other words, if you've got a system right now and it's attaching to a solid concrete deck and you want to do an EJ and you say, well, I'm going to change it over to a fluted deck, you're not going to be able to technically justify that. A good AHA is going to pick up on that. So you want to be careful of that. The documentation, okay, each EJ must be on an official letterhead from that manufacturer. It's got to have the project name, location, the date, the expiration, the details. It's basically a mini listing. Everything's going to be identified in there, but do not make the mistake of modifying that and using it on a job down the line. It's null and void once you modify it. So these are very specific to a project, and typically they're also specific system. It's not your whole job is going to be an EJ. To kind of a unique one-off, just like one small thing might be a little bit different. So technical justification's got to be clear rationale of why it is. You got to address the fire rating, the material use, and the construction. There are some limitations. An EJ cannot override a third-party tested assembly. So in other words, if there's already a third-party tested assembly out there, and the AHA knows about it, it's out there, and you try to go in there and submit an EJ, there's a good chance it's not going to be approved. And going back to that large scale deviation, you don't want to have an EJ do the entire job. If you got a head of wall on a fluted deck, you can't just come up with an EJ when you know there's miles of it. So it's got to be just something that's slightly off. And at the end of the day, it's the AHA that has that final approval. All this guideline is doing is giving you your best chance of getting it accepted. And again, it's a last resort for systems that aren't tested. So that's basically the general rules on that. Want to touch now on some products. Okay, so kind of on the evolution of fire stopping, where we started off with drywall and mineral wool, basically steel angles. Then in the 80s, we got into fire sealants and fire sprays. 2008 started introducing some intumescent tracks. 2012 is a big change because that's when the International Building Code changed to require special inspection for certain buildings. So that was a big pivotal change. And then in 2015, a lot of manufacturers started making preformed, fully cured Firestop systems. 2019 came out with some fire-rated drywall accessories as well. So like with anything, there's advantages and disadvantages to all of these. Okay, starting off with sprays and sealants, they are great for dissimilar material, like what we see on the screen right here. You got spray applied fireproofing, CMU, that works great. It's great for any kind of these penetrations. Like this is a great job here. I don't think you could possibly get a better seal. You got mineral wool, you got your spray in there. It works out great. It aids in the retention. It's available in most markets. Here again, you got a concrete beam, CMU wall, conduits. Again, this is going to be a great seal there. It's great against different materials. Now, when you're getting into the like a condo or something where you've got a whole lot of fire stopping, it tends to sometimes that insulation might go down a little bit. You got to be careful of stuff like this. So like dusty drywall edges, this is going to create comeback work. Sometimes when that sealant cures, it's going to leave that indentation when it cures. It goes up after the drywall, so you're going to have to work around the MEPs. If you're on a fast-paced job, you try to put that finish on too quickly as the sealant's curing, it could cause some checking. And you're generally going to have some comeback work on there. Remember this, relying on the lowest cost Firestop solution or lowest cost installer, although it may suffice in some jobs, like you got a small job that you got, a couple hundred feet of fire stopping, that might work. But in the large job, don't do that. Don't go with the lowest cost installer, or because it could result in far danger down the line, greater liability down the line. Give you a couple examples of kind of why we got into, I think, why we got into special third-party Firestop inspections. This one here, they use bat insulation and put this light spray over the top. That's no good. They also screwed the stud to the track. That took away the movement, so that's not any good. Here, a lot of different things on here, but one of the main things that sticks out to me, this is an intumescent sealant. I'm sorry. Yeah, an intumescent sealant used at the head of wall over here. It's not going to provide a lot of movement here, so that's not going to work. Again, going with installers that aren't certified, you might end up with some stuff like this. You're wasting material, and you're going to have to fix all that. And I think at the end of the day, this is kind of, this type of workmanship is what really led to third-party special inspections. I mean, they're just making stuff up in this picture here. So again, having to repair all that is going to cost you a lot down the line. So be cautious of that. Now, since 2015, manufacturers have really stepped up, and they've come up with a lot of different types of preform Firestop device solutions. They're fully cured, and they can install either before or after the drywall. So in this one, you see the product installed over the track, and then it's installed all in one shot. This one goes up after the framing. Generally, these have an intumescent on. They're going to stick right to the track. This one also attaches to the track, and then it installs all in one step. These work out really good. Again, back to this, you could go after the framing is done, you go ahead and install that as well. So intumescent tracks, you could put the intumescent on the track there like you see. But with everything, there's advantages and disadvantages to all of these. The advantages on this one is, yes, they are going to provide some long-term warranty. Why is that? Because they're intumescent, and intumescents are age and environment tested at UL. So they're made to perform for a long time. This is what provides that longer performance warranty. Easy to install, easy to inspect. Generally, there's no temperature or shelf life restrictions. What are some of the disadvantages? Well, sometimes they got to be installed with the track. That means you have to have your fire stopping out there in advance so that you can install it with your framing. It may require an extra finishing step. So some of these require an extra finishing step, like an L bead. So that may require extra movement. Some will require additional sealant. I mean, this uneven concrete, you still got to seal it tight, so you might need some additional sealant in there. It's got to be continuous. There can't be any damage, any breaks, so it's got to be continuous. At the end of the day, just keep this in mind. All fire stopping requires training. Don't let anybody says, oh, this is the easiest step out there. They all require training. So make sure you're getting your training from your manufacturers. Now, they've also come out with some foam products too. Okay, so these foam products, a lot of them have intumescent, some of them don't, but for the most part, they're going to provide a longer-term performance warranty, generally higher deflection. Again, easy install, easy inspections, and generally no temperature. Some of the disadvantages to this, you have to make sure the gap is the right size. If this gap right here is not the right size, you're going to be fighting this thing. You're going to take away from your movement. You're either going to have too much that's not going to provide the fire stopping because the joint's too big, or if it's going to be too tight, it's not going to provide enough movement in there. And again, you might have to put a secondary piece over that. So that's some of the disadvantages. They've also come out with drywall, fire-rated drywall accessories. Now, these will generally be color-coded, so the inspector knows that they are fire-rated. They'll also provide, again, that long-term, because these are intumescent products. They're paintable, generally no insulation restrictions. The disadvantage is, again, it breaks down to that gap size. If you got the wrong gap size, you're replacing the drywall, you got to fix it, or you're cutting out drywall. It's got to provide the right. And another disadvantage, they don't get as much movement as some of the other systems do. So you are limited on some of the movement with these products as well. Okay. Something that's come up lately is the data centers requiring high deflection movement. If you're a contractor building those, you may be seeing those. There are a few solutions for that. This is one here. It's a T-shaped track with the drywall rips on the side, so you may have seen those. This is where your deflection gap is here. This drywall rip comes over the side of it. This is field applied and cut by the installer, and then this is protecting that gap right there. It could get up to 4-inch total movement, so you get a lot of movement with these systems. There's a few different ways to do this. You could also do with this product here. That is a fire rip. It's going to go over the drywall, so that attaches to the deck. Comes in different sizes: 2-inch movement, 3-inch movement, 4-inch movement. This is going to a fluted deck, so you could see. You notice that this is 2 layers, and that's single layer. That's because the single layer could get up to a 3-hour rating on it. So that's another way you could see this. And again, if you're doing data centers, they're typically minimum 2-inch movement, up to 4-inch movement, and sometimes even higher than that. So that's a good way to counter that. Now I'm going to go ahead and pass this off to Brent. So Brent, this picks up for you.
Don, appreciate it. I wanted to circle back on a couple of things real quick. I think we threw a lot at everybody there, right, Don, in the last 25 minutes. A lot of great information, and a couple of key things stand out maybe that we're going to keep reiterating to the group here today. Just showed a lot of different products. Let's just talk about that for a second. The industry of Firestop continues to evolve. There are many manufacturers, many you've never heard of, with hundreds of different types of products. The challenge, I think, Don, you started with talking about was those listed systems and code compliant documents we're going to talk about that an inspector hopefully is reading through has lots of parameters. So selecting the product is kind of step A, which can be quite challenging because there's lots of them out there to understand what's best for your unique project. But also remember the paperwork Don was talking about at the beginning is, you know, the recipe that the inspectors, which we're going to talk about now, are going to be going off of. And there's lots of different parameters within that. So our focus here of the next section is going to be trying to put our inspector hat on for a second, or fire marshal hat, and understand, hey, what does the code say for these people? Have we dealt with it before? Why haven't we before? And if we have not yet, how can we best prepare for that? You know, we work all throughout the country and see that one of the biggest challenges, I'll say, as someone who's been trying to assist with improving this process and enforcement and you know, continuing to raise awareness on fire protection and Firestop, is the code has gray areas. I think we all know that, and Don's pointing out a lot of different products and systems and processes that really are in the code, but can be challenging to fully properly design or understand. So Firestop Special Inspection, which we're going to talk about now, in my opinion, has still some gray areas, which the goal here isn't to sound negative about that. It's to help you better prepare, and maybe here are some questions that we can think about and ask before we start this process. Because I think all of us here are trying to reduce liability, reduce risks, and reduce delays, which I hope you can take home some of this stuff and utilize that. So try to come up with some questions in areas that we have seen between, you know, our experience. And if you haven't seen it yet, to hopefully help you think a little bit differently on a project, or to the right person on the project. Maybe it's not your responsibility. Hey, general contractor, architect, owner, have you thought about this? Can we ask these questions and maybe help improve the overall process? The other thing I wanted to hit on before we get going was products again. There's a lot of products there Don just showed. Quick note for those who I just remind everybody, the product itself does not hold the rating, does not have a 2-hour fire caulk, right, or terminology like that. It's a process. And I think that's the message that Don and I are both trying to say. In my photo here is I have a metal deck with concrete over it. I have fireproofing, I have framing, drywall, Firestop, MEP penetrations. Everybody's working together here. This is multiple sections of code in this photo, multiple different tests, and fire stopping is a small piece of that overall protection. And we're putting that into an already rated barrier. So that's kind of my key note that I'm going to keep driving home, that if my role is only Firestop or only drywall or only framing or just inspection, we have to work as a team. Even if our contract isn't built that way, the listings like Don was showing you include all of those parameters. So it's not just the Firestop product installed at a 5/8 depth tool to the, you know, flush with the face of wall. The wall, the framing, the fireproofing, the deck, all those things are in there. And an inspector simply can come in to observe and report per their job and just read down that list. And fireproofing, hold on a second, you didn't install the fireproofing as listed here in this UL listing. And you could say, not my problem, I didn't install that. But in the end, that inspection document includes the most restrictive assembly is what we're going to be looking at. So we have to play together from the, let's say, the fireproofing listing to the fire stopping listing, which is the most restrictive design. And I hope that makes sense, because sometimes the fire stopping listing could require deeper studs like Don was talking about, proprietary top tracks, limited movement, different types of fireproofing. So look beyond the fire stop is kind of the message I think we're trying to say here. So why are we talking about this? Well, it's in the code. What does the code say? In 2012, I think Don mentioned the AWCI brought in Firestop Special Inspection for penetrations and joints. Many of us might have worked before then, many of us have worked after, and understand that, hey, special inspection of fire, someone always looks at my Firestop, my fire marshal, my building official comes in. Well, now the code in chapter 17 has a requirement on certain jobs for special inspectors. So an additional layer, meaning you might already have an inspector, you might already have a building official, a fire marshal comes in and looks at Firestop, but now I might need another person on that team to survey it at maybe even a higher level of detail. So what types of projects does it include? Well, The terminology is on the screen. I try to rewrite from the 2024 IBC. Some of us work in different codes, different cycles. Please check your local building code. Overall, in the IBC, this has moved around a little bit, but you'll find it between 1705.6, 0.17. Sorry, 0.17 now, maybe before, I think it was 0.16. It's moved around a few sections, but it says highlighted areas here, high-rise buildings. My opinion and definition of the code is a building above 75 feet above fire department access. So you could be working in a core and shell office building or a residential building, whatever it is, over a certain height, and now have Firestop special inspection. Also, we need to could see it in category risk 3 or 4 buildings, which we'll show on the next slide. And the new change that recently happened is group R occupancies with an occupant load greater than 250. Meaning I could be on a wood frame type 5 construction doing just apartments. And now, based on the size of that and being a group R project, require Firestop special inspection. So I think Don was saying that earlier, but the trend we're seeing in industry is it's evolving and enhancing where we are seeing it and how we are seeing it and how much may be asked of you. So if you haven't seen it yet, I'll continue to say it. Those are the most challenging jobs when a Firestop special inspector is properly enforced per code. It's been there since 2012, and everybody on the team, most of them, I've never seen this before. I've done it 30 years. Why are you asking me these questions? I always use this product. It's been signed off in the last 7 jobs I've done with you. Not that you've been doing it wrong. It's just you might need to prepare for additional line of questioning and maybe additional time during that inspection for someone to watch you or to remove materials, repair materials, and review your paperwork at a higher level. So how do we build that into our schedule is something to think about. Are we doing special inspection? Who's doing it? We're gonna go through this checklist for you. It's found in 2 ways, one for fire-resistant joints, which is our focus today on the screen, but also penetrations. So for those of us who work in penetrations, please note that there is a separate section that is pretty similar between the 2. So this is a list. Don't need to memorize this, but again, high-rise buildings, group R above 250 on occupant load, and then also category risk 3 and 4 buildings could be things like schools of certain size, universities, even malls or areas of assembly over certain sizes. It could be as small as a fire or police station with just a couple rooms in it, right? The big one we usually see it in is hospitals or areas where, you know, people, obviously we use them for emergencies, air traffic control. So a lot of these different areas, power plants could be a big one. So I think this list, hopefully you can see, hits home on a lot of the projects we work on, but not all, but it continues to grow. So where and how is it enforced? I'm showing you it could hit home on a lot of your projects. It hasn't yet. It's usually the responsibility of the design professional of record and the owner to develop that list of who's doing the inspections and how we check off the building code to meet each of these areas. You may have not seen it in the past because maybe those people or that individual or that team isn't aware that the code changed, or you know, there's many reasons, but I will try to say it starts there. I have seen it working throughout the country though. Certain building officials or jurisdictions or cities, right, may have specific parameters already in place for what they want to see. So I could go to the city of Denver, and the city of Denver might have a list of, you need to do Firestop special inspection, and you might need to pick from these qualified inspectors that we have already, you know, audited, let's say. So you could see it reversed, I guess is what I'm trying to say, where a jurisdiction has requirements. Maybe they have to pass a test. Maybe they have to have experience, maybe they have to be, whatever it is, that can vary greatly throughout the country. So I would always recommend you check with your local jurisdiction, or if you're looking for help, sometimes the jurisdiction, educate them on that and say, look, I would like a ground rules for this in the future. Can we develop a plan of action so that we see equal playing field on who does these inspections and what their qualifications shall be? That's a big one that I see. The standards, there are 2 ASTM standards we'll touch upon that are in the building code. In chapter 17, I showed you for Firestop special inspection. The list of qualifications is a little bit open. It continues to evolve where additional qualifications and potential studies are needed. But in the past, you know, you'll see sometimes somebody over here doing concrete inspection. Hey, Sally, can you run over there and do the Firestop special inspection as well? And they scribble out their report for concrete and write Firestop on the top and start doing Firestop inspection. potentially that could occur. No offense, but is the qualification of that individual, do they know what UL systems are? They've been to a training class, that they, understand the ASTM standards. That's where we try to recommend people to take a look at different things. And there is a document called ASTM E3038 that is a ASTM standard, E3038, that helps AHJs and owners and architects assess the qualifications of that individual doing the special inspection. So our recommendation a lot of times is, hey, if we have to do special inspection, maybe I'll look at an ASTM standard, E3038, and make sure that inspector meets some basic qualifications that have been developed and published by ASTM. Might be a helpful tool. The other big gray area that I see is how much, and we're going to talk about that next, but that could be a big liability on a project, is who's doing it, how much do I have to do, and what's the process? So please remember those three areas, because the amount of inspections and amount of time you as a contractor might have to spend with this role can change drastically based on how these are interpreted. You could be one person looking at just one guy randomly every once in a while, or you could have a continuous inspection. That's kind of the open challenges we see with these standards. So I want to make sure I break down what these standards in the code say, and hopefully help you and your project or your role help set that foundation with the right people, right, to understand what they're going to need to do their job. The final thing on this sheet here is specifications. The code I'm showing you does list special inspection, but I always recommend people take a look at their Firestop specifications. In there, you actually might see additional requirements or levels of qualification or levels of roles and responsibility for the Firestop special inspector and quality control individual potentially. So you might see specs saying, look, you need to have a QC person, general contractor, and they need to be auditing the barriers ahead of inspection potentially. I don't know. It could also say we need a mock-up wall, and we want all the UL listings and EJs we're doing today on the wall before we start doing any installation, and we want to, make sure we're all in agreement there. So things like that could be found in the specifications. I highly recommend that as part of our pre-construction meeting, which we're going to talk about, reviewing that as a team and making sure we all agree. Okay, so the code says it. Maybe I haven't seen it enforced yet, but if it is enforced, Brent, what's expected of me? What could this inspector come in and ask that might be different? Well, ASTM E2393 is going to be the standard you will find in the section of Chapter 17 I said earlier. So the code, International Building Code, references, hey, you have a job that met one of those requirements, you need a special inspector who follows this standard on the screen right now. You can go to ASTM's website and purchase this for yourself. It is much more than the slides show right here. I'm trying to grasp some of the key information to start your thought process. But the key element that says on how much, it's going to be randomly witness, minimum of 5% of total linear feet of each type of fire resistant joint system being installed. So I try to highlight some blue keywords there. A couple things. Random. Can I go on a 10-story building? Oh, I forgot the Firestop inspector. We're about to close out. They can just come in and look at the top floor because ceiling's in everywhere else, right? Give them 100% of top floor. Just don't look at the other 9 floors. Now, my opinion there might not be that's random, right? So setting that foundation, understand what random means to your inspector and your AHJ, highly recommend you understand what that is. Minimum 5%. The standards will list for penetrations and joints some minimums. I stress that word because I've worked on too many jobs where the authority having jurisdiction comes in and says, nope, I want 100% until I'm comfortable, or I want 50% until you show me you know what you're doing, things like that, right? These are the baseline numbers. So I recommend, even though it says minimum 5, the authority having jurisdiction and your owner and architect could request more. So that's if we're doing a good job, that's where we start. Then it says each type. That's going to be that percentage number, and then defining what a type is going to make the biggest time difference for your liability on a project, and hopefully factoring into your schedule. So a type. If you read the standard, it gives some recommendations of what a type could be. A type could be a gypsum wall meeting a concrete floor, and we're using this foam gasket, and every time it's installed, that's one type. Or it could be that foam gasket and a gypsum wall. Every individual listed system and engineering judgment that you use with that product is its own type. Or think of a project, you could have 7 different companies doing fire stopping. Each company could have their own 5%, or 2%, whatever the percentages are, right? Based on per installer, because each day you might have a new installer and their level of qualifications is different potentially. So please ask that question up front, is how much and how often and what is a type? Let's define that now, because that number can grow quite drastically. And Firestop special inspection is not supposed to be continuous, but I've seen it go that way on jobs, is all I can tell you. And then it does use the word system. So some people look at products. Our recommendation from experience is, to me, that's a listed system. Is how we break out a type. But again, check with your own project and your own team and the powers that be. So questions to think about. What is a type? How do you calculate the linear footage of each type? Once you define that, who's going out there and verifying we met our 5% of that type? Are we doing a takeoff and we have a map that shows the total linear footage of that? Whose responsibility is that? Again, the inspector can't sign off and say, we're good, I got my 5%, unless we can prove that they got their 5%, right? So thinking of that. And then what's their process? On the photos on the right, sometimes materials use backing materials like mineral wool or baccarod. Sometimes it's a prefabricated product that we have to put on before the top track. So I have to be there when framing goes in, right? But what is that process and what does that inspector need to see to feel comfortable on providing you the compliant report? That again is a gray area. I want to make sure we ask that question as early as possible, because it can go a lot of different ways. Well, I want to stand there and watch every single step of your listed system. I want to measure your mineral wool compression. I want to measure the wet thickness of the sealant. I want to come back and look at it afterwards and dig it out again. They can give you a lot of different things, right? There are some guidelines that are out there to help you hopefully set a table for that. But again, the ASTM standard E2393 does not go into great detail about the process that individual needs to do their inspection. It just says, give them a listed system that's been approved to do their inspection and then have at it, right? Here's your percentages. So that's where I've seen some disconnect of what's going to happen. And then, we found a bad one. It happens, right? Things happen. So a deficiency was found. What's the repair process? A good question to think about before we start this is, please read the standard. It talks about when you have a certain deficiency or a certain amount of deficiencies, the inspector could say, time out, I'm done looking at this. You are failing at too high of a rate. You need to go back and audit everything before I come back out. So again, schedule issue. Number two, can I dig material out or find a crack around my joint like Don was showing and just squirt some more goop in the hole? Or do I need to dig it all out, prep the substrate again, find the right paperwork, and redo the whole installation? So having repair procedures in place from the fire stopping manufacturer is going to help you a lot in the long run as well. So understanding, maybe asking those questions once we select products, hey, do we have all the repair procedures in place as well? On top of this, the inspector has the option of that 5%, that's visual inspection, didn't do a good job there. That's if an inspector is visually watching the installation go in place. That was the first slide, 5%. Alternatively, with joints, the inspector can destructively sample the material. So you can go do your work. We're done. Building's ready to be closed out. Call that guy or girl out here. Let's get this done, right? Well, what does the ASTM standard says? It says, sure, you can do destructive sampling, minimum of 1 sampling per type. We just talked about that, of joint system per 500 lineal feet. So again, who's calculating out and mapping our joints to know when we're hitting our 500 foot measurement and to pull out a coupon to measure how the fire stopping did? That can be a pretty daunting process on a big job. So what I would recommend here from my experience, some people really prefer destructive sampling. My experience, I am somebody, I guess, the proactive approach is kind of the message I'm going to hit home here on all of this. The earlier I can have these meetings, the earlier I can understand these questions and concerns Brent's throwing at me and get answers about them. In my opinion, Brent's a little biased on that. I can get answers, I can get my design in place, my schedule in place, and my process in place to get that moving smoothly, right? If I wait and, oh crap, we forgot the special inspector, we don't know any of those answers, and they come out and they're going to throw all kinds of curveballs at us, that can be potential delays and risk, right? Also, from my experience of digging materials out, there's a lot of little things you can find as these materials cure. Firestop is not a pretty industry, just to be honest. So the sealants, go in different ways, and they're never perfect, right? So there's a lot of potential discrepancies an inspector could have. The biggest one I stress is they pull it out, it was done wrong, let's say, for whatever reason. a lot of times from my experience, if it was done wrong in one spot, it was probably done wrong in a lot larger area, meaning we're now going back in a much larger volume where if I visually inspected it the first time on the first installation with the contractor, you would think hopefully we'd be able to catch that deficiency round one, not at the end of the fight, right? So a couple things to understand, because this sounds like it's going to be less to look at. What I will say is the standard says if I dig it out and I find a deficiency, I then need to witness the repair, and then I need to go and witness one additional destructive sample of that type. So it starts to snowball with this section. So if I dig one out wrong, fix it, great. Move to the next one, dig it out wrong. I'm compounding each time I find a deficiency. So this number can really get out of hand is kind of where I'm going with that. But hey, you do you. Every inspector is different. I just want to, proactively approaching Firestop special inspection, I think is going to help us. Skip the slide there. Let me back up. So how can you better prepare, Brent? You're throwing a lot of things at me. I get it. Okay, I'm concerned. Well, kickoff meetings for Firestop. I think we all do that with other types of inspection and processes. We talked about mock-up walls. We talked about reading the specs. We talked about a list of questions to ask individuals. In the end, let's just get everybody in the room who has a say in this scope and let's talk about it, right? What is a type? What is a process? What's the percentages? Here are all our ULs. What else do you need for everybody to get this job done per code, right? That's really the simple message we're trying to understand. So I think Don hit home, and I'm not going to dive too far into it, but the products can all vary. How you handle them, how you store them, when you install them, what's the cure time, how much do they shrink, what's the inspector going to want to measure, right? All these different things can factor. So just want to remind people of just ask. It's scary, I know. We always don't want to be that transparent. Brent, it never happens to me. I'm just telling you, the jobs where it does get enforced, it can be a major, monumental task. Popping ceilings all closed up, ducts are in the way. How do we get in here and do all this stuff, right? It is not a simple thing. Firestop usually is highly concealed as the job goes on, right? So earlier the better, and whose roles and responsibilities are what. On top of that, honestly, proactive design. I get that not all of our jobs are design build or, our responsibility to handle the Firestop design, or maybe it's subbed out to some other company that the GC is managing, right? Or something like that. But in the end, there's some basic things that we can review, hopefully early in design or earlier than permit, even if possible, to ask basic questions. Like the plan on the right said, look, hey, you're showing me a U419 gypsum wall, 1 hour or 2 hour wall right next to a column where that arrow is going. I can't get in the backside and screw my drywall off, let alone put Firestop. Shouldn't we just switch this to a shaft wall and then look up those UL listings for that? But again, if I don't ask that question up front and I'm standing there in the field with the inspector saying, well, that wasn't my responsibility, and now we're looking for an engineering judgment like Don talked about, or some sort of change, you can find yourself with much more resistance from my experience. And Don hit on that. I want to make sure EJs, a growing trend we're seeing is if you're more proactive and you can show your math, like I've said before, it's going to help your AHJ be more open to accept them. A growing trend that we're seeing out there is the question. I do a lot of engineering judgment design and presentation for a business, and I'll sit down with the fire marshal. One of the first questions is, Brent, hey, one, prove to me why we have to do this, EJ. Nobody has a solution. I don't care if you're using brand X. Prove to me, what else is out there. Number two, how many or how much does this occur? Oh, this happens on 90% of your building? Whoa, timeout. I'm not talking about this, right? Or it's 3 conditions on the project and you moved walls on these other 10 over here to eliminate it. All right, I'll talk to you. So that thought process of if you can show your proactiveness and not just assuming that you can get a piece of paper to get you out of a jam or get it stamped by somebody and things like that, it doesn't always work. It might have in the past, and we're seeing a growing trend where fire marshals will say, nope, pound sand, not approving that. You should have thought this through. Go rebuild it, go fire test it, go switch manufacturers, not my problem. So please keep that in mind, that engineering judgments as an industry and as an out continue to get more restrictive and more challenging to get approved. And if we can just think through some basic items, hopefully we can stay ahead of that, right? So on the home stretch here, I wanted to finish with a few different items here, if I can get my slides to work. You want to try it there, Don? Yeah, I don't know if that's you. Doesn't want to move forward for me. There we go. I'll jump to here. So fire testing, let's just think about that for a second. We're talking about listed systems and products. Brent, products don't hold ratings, you said. The system does, right? So I had to go and test and prove that this stops fire. So this is an example of an ASTM E814 test, which is for a through penetration. That's okay, not what we're talking about today. But I want to show, because joints, fire resistant joints, tested to a different standard, go through basically the same procedure. We put it in a furnace, we burn it, we see a flame promulgates through that joint. We also verify how the temperature of that joint, as Don was talking about, is evaluated and keeps cool. And then we hit it with a host stream, which is the most challenging part of that test. And why I'm trying to finish on this as a message is we're all working together. We're all playing in the same pool. Fire protection, we know, is an extremely important part, and Firestop and passive fire protection is a small piece of the overall fire protection of the project, right? But to get us that piece of paper, that UL listing or Intertech listing or whatever it is that says I'm code compliant, inspector, read this, say it's okay, I'm going to install based on this, it is a very challenging process and a rigorous process. It's not easy to pass. So here's two pieces of steel penetrating a shaft wall. One thing I wanted to point out was when you have an asymmetrical wall assembly, like Don was talking about, shaft wall in this case, or asymmetrical fire stop installation, I have to test it both ways. So I have my shaft facing the fire and I have my shaft facing out of the fire. Then during the fire test, you will find different things occur, but we're looking for flame promulgation through that joint. So try to turn the volume down. Hopefully this works. Let's see if it starts to go, Don. Sorry if you can maybe hit the button. It looks like mine's not working. But what this photo shows a couple different things is the intumescent material is the black material there is actually expanding and filling that annular space or joint. Also, we'll see those pads. Those are thermocouples. So as we talked about, we measure the temperature performance of the joint and the wall. So joints and walls have to keep at a certain temperature. This is an example of an intermediate furnace at Intertech, is one of the accredited labs we see throughout the country. And what we're trying to show, you can see on the ground there's even intumescent materials falling off. So intumescent means it expands with heat. I want to remind people that not all fire stopping products are intumescent. Many of the sprays and sealants you see in fire resistant joints are not. And the mineral wool behind those materials is really what's doing the fire protection heavy lifting. So this is an example showing that during the fire test, things happen, things move, things, can expand and contract. And then what happens next is probably one of the most important slides. If I can get there, maybe Don, I'll let you do it, or whoever's driving, Tao, I apologize if you want to hit the slide, is showing the drywall right there. So if you haven't seen drywall, there's probably people in this room that are much smarter than me on drywall potentially, but look at that picture right there. This is after 2 hours, the drywall, look at all the seams and the cracks. So understanding how your wall assembly is built and how the drywall comes together, how it's screwed, how it butts, how it overlaps seams. That right there, those photos show you how important the seams are and the annular space around the elements and in the joint, because those seams opened up and now heat and flame got into my stud cavity and started affecting my cold side of the barrier. So what I'm trying to show here is we know in a fire test that the fire side is sacrificial. About 20 or 30 minutes, each layer of that material, the board, 5/8 type X, starts to go. That's okay. What I'm trying to show here is look how much morphing did occur there on that drywall. Look how big the seams got. Look how much cracking occurred in the drywall. So if that wasn't properly installed, Firestop, sorry, you suck. You're gonna, have some challenges. And what the next slide shows in a fire test is that we actually then for joints and penetrations, we actually hit it with what's called a hose stream test, not to simulate a firefighter, but to verify that the fire stopping materials will not dislodge or loosen in the event of large amounts of pressure that occur in a fire, right? And think about a fire resistant joint like Don was talking about. Some of those buildings move substantially. So we have to cycle our joint ahead of the fire test. Then we leave it in its most vulnerable state, burn it, and then throw it through this hose stream test. And if we fail any component there, we fail. So this video is showing a failed test. That's the reality of fire testing. That's the reality. So from that, what caused the failure with the finishing slide, we'll kind of go there, is a couple different reasons. But one could argue that our wall assembly here was not built right. Oh, I hit the button. I apologize if you go back. The wall on the right is completely gone. So since the wall construction itself did not hold, my Firestop did not hold. Meaning we all need to work together. Firestop, framing, drywall, fireproofing, general contractor, inspectors, all these elements need to play in the same pool, because the fire stopping listing talks about all of those items. And if we're not all reading each other's documentation, one screw goes in wrong, leads to what's on the screen right here in all reality. So I'm not trying to get too far into the weeds on it, but just keeping that big picture thought when you're doing Firestop pre-construction preparation. We need to bring all people together that touch that barrier and make sure we all understand each other's documentation. You're cutting the holes for MEPs. You need to read MEP ULs to understand the opening size and how their wall construction is, to make sure we're all playing nicely together. So with that, Don, we'll finish up. Appreciate everyone's time, and maybe we'll have some questions and answers. That's my contact information if you want to talk further. I appreciate putting that up there, and yeah, thank you for your time today.
All right, thank you, Brent. And Don, a couple questions here. What is the practical use of joint systems that list movement as compression only or zero extension?
I mean, Don, I've seen projects. So when I get asked about movement, Don, I guess I'll jump in, because a lot of times we ask the question to say, look, how much movement does a structural engineer of record design on the project? And we get answers like 3/4 inch deflection is a lot of times what we hear, or something, right, Don? And then I'll say, well, time out. The fire stopping listings, right, Don, say compression or extension, or the question is, the listing said compression only. I have seen structural engineers come back when I ask the question of, please define what way your movement goes. And I have seen structural engineers say the project gets compression only. But that has to be defined by that structural engineer of record, Don. I don't know if you've seen otherwise, that it's kind of out of our hands as, let's say, a manufacturer or design professional or a contractor. That structural engineer is going to tell us which way the building moves to kind of start the process. I don't know if you have other experiences.
With like snow loads where it's compression only, you'll see it. And typically systems that could even do that, go compression only, are typically systems that are 100% movement. You won't typically see that in a fill material. It won't have that. I take that back. I know there are some listings that will, even on a fill material, do a compression only. The percentage will be a little bit different, but generally it's got to do with the building. If a snow load or something like that, maybe they only need one-way movement. So that's the only place I've seen it. But yeah, you could do that.
Next question, I think you might have mentioned this, but what is the remedy if a contractor install drywall screws too close to the underside of the metal deck above?
I'll touch on that one. So what that's going to do, it's going to prevent your movement. So when these are tested, they really spend a lot of time showing exactly where that screw is going to go, because if it's too high, that drywall is too tight and that screw will hit the bottom of the track as it cycles up. So that's why it's so important that that screw is in the right location. Now, hopefully the UL listing will give you a little bit of a window, like 1/2 inch, 3/4, 1/2 inch to 1 inch. If not, you could have an inspector that is going to take a tape measure out and want it exactly where it's identified in the UL listing. But bottom line is that screw has to do everything with the movement. It is a very important facet of that assembly.
And then we always hear the AHJ can override a UL or EJ even if you do it correctly. So how can we dispute this, or is there an avenue we can take?
It's you, Brent.
A broad question, I guess. It's kind of two different things. Let's just look at if a listed system was questioned by the AHJ, maybe was the question. EJs are kind of case by case, right? It's their liability of wanting to accept that. So if I had a listed system that's questioned and saying, I interpret it this way, you interpret it that way, a couple of different ways I would say. One, I start with the manufacturer who owns the listing and see if their technical team or their representatives can provide a documentation, sometimes a letter or a clarification letter explaining, that was a typo, or it really means this. That's kind of step A. Step B, sometimes you can either have the manufacturer or find the right contact to talk to the laboratory yourself, the listing laboratory. It's a little more challenging. Or step C, I would say sometimes, unfortunately, a fire protection engineer or an engineer of record might need to come in and analyze the questions and the conditions and provide an analysis and maybe a stamped document license in your state to provide explanation, and discussion points. All three of those in the end, I think the reality of it, Don, I don't know if you agree, is the AHJ still could say, I don't care. and this is my interpretation, go fix the listing until it's reads this way. So kind of a broad question. I hope that understands some basic starting points, I guess I would recommend. But talking through that as hopefully a logical process and understanding the concerns, and that fire stopping listings, just like the code, aren't perfect. And sometimes you're going to have those types of questions coming up. Yeah, EJs are case by case. Again, I guess it's kind of the same answer. If they don't accept your EJ, I tried to show you some items that I recommend. IFC has some guidelines Don mentioned at firestop.org you can look at, basically saying, prove to me there's no UL listed system available, show me where it is, justify how you accept the EJ as a manufacturer. So just kind of showing your math of how we connect the dots to the manufacturer even accepted that. So many times your manufacturer can provide you a letter on top of the EJ that helps connect those dots for the reviewer. Sometimes you go to a third party again. Again, the FPE might have to get involved to do a third party analysis and a potential stamp on that document to, again, show that them as a third party, they agree and can connect the dots as well.
Great, thank you. Next question is, host stream test important for all types of fire stopping assembly?
It's a part of the test standard, right, Don? So I was trying to show a through penetration. We always do it for walls and floors. Fire resistant joints, Don, remind me, it's head of wall, wall to wall, and bottom of wall. I think we always do host stream testing, but I don't think we do it for floor to floor joints, if I remember correctly, or floor to wall. There might be a couple we don't, but common drywall assemblies, we're always doing that as part of the test standard. So it's not something, I want to make sure I wasn't confusing people. I'm just showing you behind the scenes, we need to go through those steps per the code standards. And then if we pass that, we get you your listed system as a manufacturer, right? So if we don't do one of those things, you'll never even see the listed system if you can't pass that. It's kind of, right, Don? Am I missing something there?
No, you're correct. You don't get it without that hose stream. The US, I believe, is the only one who's doing the hose stream like that. It is for rapid cooling and non-combustible construction. So what they're looking for is that nothing blows out the back when they rapidly cool the system. It is a very tough test to pass, like Brent was saying, but it is required in UL 2079 for those joints, head of wall, bottom wall, wall to wall joints for that.
So nothing we would ever do in the field, or nothing that a project would have to do, right? As long as you have that listed system, they've already done it.
Yeah,
it's
exactly.
not like a special inspection step. Make sure I was clear on that.
Correct, yes.
What qualifications should a contractor or GC look for in a specialty Firestop contractor? And also, do you see benefits of the Firestop installer labeling their installations?
That's a good one for you.
A couple different things. I would say if you need more training or understanding of that industry, there is what's called the Firestop Contractors International Association, FCIA.org. Great place to look, just like AWCI, for specifics on contractors that are available, training programs, and their qualifications. So what do I look for in a Firestop specialty contractor? I think it's just like with any contractor, right? It's gonna make a difference for everywhere you go, and the competency and experience and understanding of the documentation and materials we're working with. So I think maybe some questions that we would look at, or I would recommend you ask, is kind of the theme of the day today, right? Don showed you how detailed those listings can get. Does your specialty Firestop contractor, are they versed in the listed systems? Are they versed in how the products can be handled, how they cure, how they're repaired, right? The kind of these questions we're throwing at you today, just double checking that the individual and company you're going to potentially hire went beyond the basic, I've done brand X training and I've done projects before, right? How much do they know in the paperwork, I guess, is kind of my line of questioning to think about, because that's what these inspectors could be asking more questions of, and putting those people to, the competency as to. And then the second question was, I apologize.
Do you see benefits of the Firestop installer labeling their installations?
Two things. I had a slide, I skipped over this, I apologize. From my understanding, the current 2024 IBC says we are to label the barriers currently by code to say 1 hour smoke barrier, right? I got stenciled out on the wall. So that's in the code. Labeling of penetrations and joints are still unfortunately not listed in the code. There is an ongoing push to get that in the code, and it might be in future cycles. There is even an ASTM standard, I believe, that has been developed that you could look at, if not in the code, but if you'd like to utilize, could help you on your project if there's questions about labeling. But in the end, labeling usually is found in the specifications. Most project specifications, I think Master Spec calls it out. So code doesn't say it, but your specification 07840 most likely do. And as somebody who does a lot of surveys of existing buildings and new construction, I highly recommend projects take that little step to label the Firestop. I'm able to then hopefully as a general contractor or inspector say, okay, Joe or Sally installed it, their company is on there, the listed system they installed, the date, to show hopefully a little added level of competence, right? That someone took the time to verify what goes where and hopefully help facilities if repairs or damage ever occur, right? That could be on that label to help them understand what products and systems were done. My disclaimer is, please still check the UL listing that is on that label, because I've seen a lot of labels with the wrong, information on it. But definitely a helpful step during construction and inspection for the inspector to feel more comfortable, and the facility in the long run understand what they got and how to repair it if ever needed.
All right, last question here. This came during one of the videos that you showed. So does it seem like the MEP penetration focus on deflections at the top of wall? Are these MEP testings not being tested for deflection?
Don, I guess I'll jump as my video. Yes, we isolate them per code. Section 714 is penetrations. Section 715 is fire resistant joints. Both sections of code have two different test standards. So we isolate each item. So in that wall, yes, there was a joint hypothetically around the four sides of the wall. That was not part of the evaluation. They're focusing solely on that penetration through the middle of the wall. Don, then you would go and do a different test, right, of a shaft wall, of the header wall, and we would again build the whole wall in that furnace like you just saw, but we would isolate just to that top part. And then, so why I think, Don, you showed a picture earlier, we don't want to play together, right? You showed that penetration through the header wall. That's where we get into no-nos, right? Because they're tested usually separately. And a lot of times our friends in the MEP world get a little close to our joints. Or Don, I don't know if you talked about no-fly zones or you have any experience about that, but we try to keep them, away from each other. It's like your screw point, right? There's certain heights that the header wall listing's got to follow. And if the MEP gets too close, we might now affect that movement, right, Don, or the overall design of that assembly.
Well, that concludes our Q&A session and presentation. Thank you so much, Brent and Don, for the informative presentation. Thank you, attendees, for joining us today, and we'll see you next time. Have a good one, everyone.